And we're recording. This is Kubernetes SIG Network from Thursday, August 6th, 2020. We're going to start off with Bridget, who's going to lead us in some issue triage.
Okay. Let's take a look. I am sharing. So theoretically, people can see my screen.
Yes, I can.
All right, we're going to start. We have a flaky test. Yay for test flaking.
Oh, just assign that to me.
All right.
This is Bowie. B-O-W-E-I.
All right,
Yeah.
that was fast and easy.
I think we're actually having someone take a look on our side, so this may already be covered. But just assign the L7 ingress flakies to me.
All right, fantastic. We've got next up, AWS ELB forwards traffic to deleted pod. And somebody suggested, sorry?
I don't mind taking this one. Andrew second.
All right. Drew.
That's fine.
There you are. With the clicking. Magical. We're going to get through these so fast. Start, stop, Damon. This seems exciting. Interesting that this is Alpine and it's claiming that the kubelet doesn't exist.
Either way, it doesn't seem much like a network issue.
I mean, yeah, it's confusing because, I mean, I don't have Alpine handy, so I can check and see what the path to kubelet should be, but that seems like a proximate cause is maybe your RC scripts don't have the right location for kubelet. What SIG is the right place to
why
send
is this
this?
tagged with SIG network? Oh,
yeah, exactly.
Because AthenaBot is making.
AthenaBot's guessing. What do we think?
Assign this one to me. This is an easy one to follow up on.
Yeah, okay.
I'll score those points.
Casey, there you go. Have fun. Failing tests. Ooh, flaky tests. Who's been looking at this? Okay, Liggett, Jordan.
Yeah, we are on it. You can assign this to me and I'll pass it off. This is Rob Scott.
Rob Scott.
Yeah, that's me. Thank you.
All right. Nice. Ooh. For some reason, someone has an IPv6 only cluster because they don't like the internet or services. I don't understand, but for some reason that they do, and
Looks like Jay's looking
Jay
into this one.
looked at it. Do you want to go further with this, Jay, or what do you think?
If you want, you can assign it to me too. Yeah, I was just helping Matt look at it, and I talked to Antonio earlier, and it's just the node local DNS. He was telling me about it. It doesn't yet support IPv6, so that's the real fix. But
right,
it seems to me like we need to log that in this anyways. That's an easy thing, at least for until that feature is actually supported.
Yeah, well, that makes sense. All right.
Who is maintaining the local DNS? Anybody know?
Yeah, it would be Pavitra. You can tag her on this too. P Ramesh J.
Oh, okay. Let me just reopen that.
Sorry.
Oh no, it's fine. Just gonna reopen it with. Should I also assign it to her, or should I just?
As well.
All right.
No, maybe I don't know. Somebody wants to add the feature of IPv6, and it would be good to contact the maintainer.
Good first task.
All right, and it's who? What is?
P as in Peter, Ramesh, R-A-M-E-S-H. There you go. First one.
All right. Does /assign work to a bunch of people? I think it probably does, but we will see. Hey, look at that. All right. We're just booking through these.
I don't know why we're amazed when the bot does something that it obviously should be doing.
All right.
But we are.
Here we are. Error assigning spec.podcider to nodes. Oh, behavior during an upgrade.
Is this SIGNet or we touch this one sometimes, but I don't know if we really own it.
I think it is. I think we own the allocator.
I think this is expected. I don't think we reject changes to PodCider during the API validation.
I mean, it looks like we're specifically saying node updates may not change PodCider. So I hate to reply with like, yes, we expect that, because this says they think that it would.
Why don't you assign it to me? We've dealt with something similar with GCP and preemptibles, and I'll link them to the reference stuff.
Cool. All right, thanks, Tim. Okay. More flaky tests. Let's see, this has not been looked at.
Yes, please assign to me or Rob. This is probably part of the whole related issue.
Okay, Rob, you want on that too?
Oh, either way, it'll get to the right person. Sure, yeah, more the merrier.
So much
Perfect,
excitement.
thank you.
Excitement and adventure. All right, we've looked at this one before, I think. Tim is saying, wants to know what SIG CLI thinks, has been putting detailed stuff
Oh, yeah,
in.
we should remove the triage from this. I think this is a feature request.
Okay. Do I need to say anything else to it, or just remove triage unresolved?
/kind feature.
Okay. And it would be great if I could spell.
Kind.
Mm-hmm. All right, anything else?
I think that's sufficient.
Okay. How are we doing on time?
Got about 4 minutes left.
Wow, we've gotten pretty far. All right, what's going on with this one? This is asking for more info. Do we consider this to be triaged or no? Because we don't have enough info yet.
Sorry, my audio cut out there, but yeah, I don't know that there's any. I think it's still unresolved, but I am taking care of it. So.
Okay, let me grab the. I actually didn't open more issues than this because I didn't realize we would go this far. So I'm just grabbing the URL again. So this one we're leaving because we don't really have anything for it. And let's see.
Looks like we're getting into ones that we've already.
Yeah, we're getting into ones we've definitely already seen, but let's take a look. See if there's a few of these older ones we can do something about. And see, I mean, Antonio asked for more info.
Yeah.
What do we do when they don't write back?
Usually it's a ping, and then if at the 28 days, 2 weeks mark, we still don't have anything, then we go ahead and close it and ask them if they're still have anything they can add to it, they can reopen.
Yeah, that makes sense.
It's a little aggressive, but it's the only way we can manage these dead ends.
It looks like this one, people really want Tim's opinion.
Yeah, it's starred in my mailbox. I just haven't gotten to it.
That's cool. All right, let's see. It looks like we assigned Freehon in this case. Unfortunately, this was 28 days ago.
So we are updating the RBAC. So it's an RBAC issue.
Okay.
Yeah, so it's getting fixed. So.
Okay, do
Yeah, I will update
do we
it.
consider this triage unresolved still, or?
It's triage.
Yeah, you can remove that and kind bug.
Okay, kind bug. It's a kind bug. It's not an unkind bug. I really want to type king for some reason. All right, so that's that one.
We can do one more.
All right. It looks like.
It looks like I am due to follow up with this one.
Okay.
I think, yeah, okay. I have followed up with this one, and yeah, in progress. It was a over-aggressive timeout in the test, and I think I could increase the timeout even further. The reason this is failing is garbage collection is taking too long. It's not even really an endpoint slice thing. It's yeah. So I'll follow up again. Thank you.
Is that useful for me to put in to jog your memory?
Yep.
All right. And I think we are done here. We got a lot done today. That's awesome. Thank you all.
Thanks a lot, Bridget, for walking us through that. Cool. I see we are still getting items added to the agenda. Laura, you were next. You wanted to talk about Sano tables-based proxy. Is that like a presentation, like slides, or do you just want to point folks at?
Hi, can you hear me properly?
Yep.
Okay. Yes, I have some slides to share.
Okay.
Very
How
briefly.
much time do you think you would like?
Few minutes, I think, no more 5 minutes.
Sounds good. Take it away.
Okay, can you see my screen?
Yep.
Okay. Okay, so this is very briefly a presentation about QV NFTLB project. This is a project for some years now, and some people involved, including Balonera, NetFilter maintainer, and some engineers from 7net. So first of all, we would like to explain a little bit the application stack that is used in this project. This project is based on the motivation of consolidate NFT tables, not only for firewalling, but also for load balancing, and to reduce the application stack needed for load balancing using NFT tables. So during the application stack that we are using right now, we are based on the NetFilter infrastructure, both kernel and user-space infrastructure. And we are just going to need NFT tables and the contractors. For that, we could get rid of all the infrastructure needed for IP tables and all the derivatives of that, include not only for kernel but also in user space. So we are reducing here quite gently the infrastructure needed for load balancing, including IPVS. On the other hand, NFTLB, this is a daemon, event-driven daemon in user space pertaining C. This is a daemon that accepts a JSON API that traduces JSON configurations into NFT tables rules. via a library called libnftable. So we are not using shell command line. Also, it has a netlink network interaction for discovery, as the daemon interacts with the networking configuration and events like MAC discovery and IP or even network interfaces. Some key features like auto hook generation. So we only are going to use hooks that are really needed, not all hooks that are created by default, like in IP tables. Also, connection tracking offload using flow tables for acceleration of traffic. We are also using early hooks, so it's more optimal for the traffic, and also virtual service indexation. The next layer is Cube NFTLB. This is a wrapper written in Go. This is a work in progress project for what we have at the beginning designed with just one pod, one container, but two processes. One client, which listens or the Kubernetes events, and a daemon, which is instantiated with one NFTLB daemon. This is just one instance per Kubernetes node, of course, optimized for multi-services. This is a draw about the architecture. As you see, in just one pod, we have one container and two processes, client and daemon. This daemon generates a batch of NFT rules, which are sent through netlink to the Netfilter infrastructure. So it's quite optimal in terms of interaction with netlink sockets. What we already support in Cube NFTLBs that enables external and internal connectivity, some multiple services, node port services, some protocol support like TCP, UDP, SCTP, or combination of them. We already support native dual stack, session persistent by source IP with a TTL, service port netting to backends, and some annotations that we are extending, like some helpers in order to interact with some application layer protocols, some advanced LB algorithms, and also traffic logging. We are currently working on DCR. We have successfully tested in Kubernetes infrastructure. We are just integrating it in Cube NFTLB in order to automatically generate and create the loopback interface for the backends. And also, we are expecting to have the egress hook in the filter, which will be required for interconnectivity inside for DCR inside one node. Also, we're working on supporting network policies. We expect to be very easy because we have something very similar that we call security policies. So it should be very easy integration. External IPs, we are designing right now the option to support a list of virtual services and also metrics. These are work in progress tasks that we are doing right now. Some next steps that we want to share with you are, for example, that we are open to some design discussion of this project if you feel that this is a promising project. We are working as well the option to support some advanced features that we currently notice that the Kubernetes API is lacking. For example, some configurable session persistence, some virtual service connection limits to avoid, for example, the number of current connections. Also virtual port ranges or some features like backend settings like weight, response, and purity if they are really needed. And also connection tracking acceleration by default as we already support it in NFTLB. So the next slides are more to show, for example, some rule sets that we are generating right now with this project. As you can see, these are very optimized rule sets. And also some examples about the hooks and how we do create virtual services in terms of what kind of virtual service configuration is it's going to really need it, like this NAT example, or pod to pod, or external access from an external client to several pods inside a Kubernetes node, or even from user space. We have also some cases for DSR. So we can show here the uses of the different hooks for different use cases, and just to show how internally this is working, or how we were able to do that. And that's all. If you want to. If we can explain something else more deeply, just we are open to discussion of this design, and that's all. If you have any question.
Thanks, Laura. Does anybody have any questions for Laura?
I have a question. So how did you allow network policy to integrate with this? Does it comes with the network policy implementation, or like basically what's the basic handshake between network policy and NFTable kubeproxy?
Well, the main idea is to use our security policies, which is mainly blacklist and whitelists, and that are able to be applied per service, per virtual service. So we can reduce the events of Kubernetes to create these objects to generate the lists, and also to be applied to several virtual services. I don't know if this is your question.
I see. I have a question. This is really cool.
Yeah.
How do you compare and contrast this with the eBPF-based implementations?
Well, we haven't tested eBPF, but some benchmarking that we have been seeing on several web pages doesn't seem to be very much performance that we got with NFTables. And NFTables is right now a language with very much expressivity that IP tables. So we can consolidate pretty good all the load balancing requirements that we need so far. And even if it doesn't, we are open to integrate it quite easily and quite rapidly. So currently, NFT tables, we think, and we are in the load balancing market for a long time. It's perfect for all that we have been requiring to do.
So I have another question. So since this is implemented using NF tables, I assume the container interface setup, like there's not much more dependency than the IP table based proxy. So basically what I'm asking is that the CNI container interface setup can be decoupled with this NF table implementation. Is that correct?
Well, we are using the same API, but Cube NFTLB is independent completely. So we can remove Cube proxy, and then using the same API, we can generate the whole connectivity required for load balancing.
Got it. So I have one more question. Sorry.
Yeah, sure.
So regarding the DSR, so you showed an example from the user space program. So does it come from the same? It has to come from the same node, or like can it be like outside of the cluster? Like
yes, we have three main use cases for this DSR. We have tested very successfully, which are the first case is pod to pod. The other case was external client to a certain port. And finally, the use case for from the same node in user space to connect to a service in the same node. So these three cases has been successfully set up.
I see. Then how did you carry the those information, right? When you do the DNATing, where do you stuck in the necessary information for the server side to respond directly to the client?
The daemon has some objects are stored in memory. So using the JSON API, you can configure in live any attribute for those objects, or even to dump the whole configuration and then set it up in another node. So using the JSON API, you have the whole configuration.
So I'd like to make sure that we get to the rest of the topics on the agenda. We're halfway through the meeting now, so I think let's cut off questions there. And Laura, could you make sure that
just to finalize, if you want me to share the slide, I can send it without any issue. And if you have another questions, you can contact me through email or through a new ticket.
Perfect. Okay. Thank you for that, Laura. Rob, you're up next.
Thank you.
That looks really cool. Thanks for sharing. This is just a really quick presentation. I wanted to introduce Rick Chen, who has been interning with us this summer. And he's been helping us evaluate algorithms for topology-aware routing. You may remember an email from Tim a while back and a discussion on the mailing list about how we could potentially make topology-aware routing automatic. And of course, that would require some form of algorithm to do it. And Rick has been very helpful in helping us figure out exactly what that might look like. So with that, I'll hand it over to him.
Hey Rob, thanks for the introduction. Hey everyone, my name is Rick and I'm currently working with Rob on this problem. And without further ado, let's go into the project. And I think some brief context should be helpful, though most of people know much more than this. Is that currently when a request comes to a service, it ends up being equally distributed to the endpoints behind that service, no matter how those endpoints are distributed in different zones. So what we want is to keep those traffic local in the same zone. That's to say, when a request is sent from a zone to a service, one that request ends up being assigned back to the same zone where it came from. So, but meanwhile, don't want to overwhelm any endpoints with too much traffic. And we decided to create an automatic tool to evaluate our different algorithms to play with different data. A very short story before this is that we got a Google spreadsheet to evaluate a single algorithm with very simple input, which we think is not enough at all. So we created this automatic tool which can let us play with more realistic data and with more algorithms. We can evaluate different algorithms and compare them and prove them. And basically we abstract some key concepts in Kubernetes, including endpoints, endpoint slices, and zones, and use the algorithms to output the distribution of endpoint slices, and then we evaluate those algorithms with some metrics we think are important, which we'll go into that later in following slides. And here's the GitHub link. Feel free to play with that tool. And next, please. Before going to the metrics, we have to mention two assumptions we use for our simulation. One is the traffic will be proportional to number of nodes or number of cores or computation resources in a zone. And the second assumption is that capacity will be proportional to number of endpoints in a zone. And feel free to challenge or question these assumptions. I think Rob will be very happy to answer your questions. But before that, we just keep that assumption to work with our project. And then we evaluate our algorithms based on three metrics we think are important. First one is the in-zone traffic percentage. That is, say, how much traffic stays in the same zone. We want to keep as much traffic as possible stay in the same zone. So, but meanwhile, we do not want to overflood any endpoints with too much traffic. That is to say, a good algorithm should evenly distribute traffic across all endpoints. And last but not least, we all know that there's a price when we create an endpoint slice. So we want to reduce the overhead with our algorithm. So a good algorithm should minimize the number of new endpoint slices required or created. And we have been working on two algorithms so far, which are very rough ideas, not mature at all. So we'll not go deeper into those algorithms. Feel free to give us feedback. The first algorithm we're working on is called overflow sizes. That is to say, when a zone has actual endpoints and expected, that's to compare to the ratio of nodes that zone has, we assign those extra endpoints to a global slice that every zone can send traffic to that slice, and other endpoints stays with the same zone in a local endpoint slice. That is to say, it can only receive traffic from the local zone it belongs to. And the second algorithm is much more straightforward, that we just assign extra endpoints to zones who have fewer endpoints than expected. It's like we manually assign endpoints to make that distribution match the ratio of number of nodes in every zone. And that's just very rough ideas. right now, and we are trying to improve those algorithms with our tools, and as well find some new algorithms. And let's take a look at how our input and output look like. The left-hand side is the input file we use. Is a CSV file that with different combinations of zones. The first column of the zone is the number of nodes, and second column of the zone is the number of endpoints. And this is the input file we use. We created like for some representative data set. And the right-hand side is the diagram created based on our output CSV file. We didn't put that here. You can find the output file in the GitHub, and just give you a very rough idea how that looks like. Let's take an example. Look at the only one endpoint data input has a very low score. That is quite intuitive because you only got one endpoint. We've got 3 zones, so there's no way that you can get a very high score in zone traffic score, or like since it's a local algorithm, it can either get very good traffic distribution because some of the traffic can go to that endpoint sizes, can go to that endpoint slice. And yeah, that's pretty much about what we're doing right now. Here's the GitHub link. Feel free to play with this tool and give us feedback, suggestions, or some new ideas. We're very happy to have you working with us. Yes, thanks.
Yeah, that was a great presentation. One thing I'll add is, yeah, like we would love additional ideas for algorithms. The algorithms we have right now were mostly to test the tool and ensure that given an interface, we could score an algorithm appropriately. Obviously, both of the algorithms we're implementing right now have holes in them, but I know there's probably plenty of ideas out there for how we could approach this. And now we actually have a way to just plug that into an interface and score the result with a wide variety of inputs. So yeah, it's a really cool project.
Yeah,
So I think this is awesome. And I especially love the idea that we can try out different algorithms. What is the plan to, like, when do we turn something like this into a KEP? Because my sort of gut feeling is more or less we can't do worse than we're doing today.
Yeah, well, you would be surprised. We have found ways to do worse than we are doing today. But yes, I agree with that concept. I would love to see this get into a KEP in time for the 120 release cycle. That has been the goal. I'd like to have a few different algorithms. I think both of the algorithms we've implemented so far don't make sense on their own. I'd like to get an algorithm we're a little bit closer to happy with before we turn this into a KEP. It doesn't need to be a perfect algorithm, but right now we have an algorithm that works well for small sizes and an algorithm that works well for large scale, and not one that does particularly well for both. So there's lots of different options here. I'd just like to get a little bit closer to a solution here, but great question.
Isn't this one of the laws of operating systems? There is no heuristic that works well for both ends of their spectrum.
Yes.
Yeah, I have one question. What is the size of the endpoints that you are managing when you say large scale, small scale, and the things?
Yeah, so this is not a perfect example at all, but the largest example we have is this somewhat balanced huge, and huge is maybe not the best term here, but this indicates 300 nodes in zone 1 with 654 endpoints, 300 nodes in zone 2 with 704, etc. So the largest number is still under 2,000 endpoints. So we should, the end goal is to test this with a wider variety of inputs, but this was just an easy way to see where algorithms were strong and weak instead of just getting an overall number.
And so the topology is, I mean, the endpoints are not ready until the topology does the simulation, right?
Yeah, so this is not actually interacting with the Kubernetes API. This is just simulating what the API resources would look like.
Okay. Well, it's a nice step to see. Thank you. It was also
cool.
Cool. Thanks, Rick and Rob. I think we should move on to the next item, but if there are more questions, where should folks find you? Bring it to the mailing list?
Yeah, that'd be great.
Cool. So I think we should try to move somewhat quickly through these next topics. Colonel Tom, you are next. Can you
hey, this is Ritesh here.
5 minutes?
Yes, so we have been discussing this issue on the mailing list around adding some new capabilities into how DNS is managed in the internal network within the K8s primitives. And I think the last update was if there are no other better suggestions, we should look into working on a KEP to make a formal proposal to how things should change. I just wanted to bring it up in this meeting, and if somebody wants to help out, they're most welcome. We can work together. Otherwise, I'll figure out what needs to get done for the KEP end and get that going. So, well, did you all, I'm not sure if you all can hear me.
Yeah, so we have, what, 2 workable ideas that we proposed, I think? So do you think we should keep them both and carry the discussion on, or do you think there's a clear winner?
I think the first one is a clear winner. Having a default service backing a namespace, I think that's a much wider audience. That seems like there might be other implications that are not obvious versus just adding a subdomain that can be routed to a service. That's my instinct. I would, if you feel that we should do 1 and 2 as one KEP, I'm fine with that. Otherwise, we can split that up and see. They both are very interesting, and I think they both offer a very different set of features. As people map tenancy into namespaces, the ability to have a deployment or a service that backs a namespace DNS address seems like a powerful primitive. And it happens to solve the problem we are facing. I don't think it is necessarily, it's not necessarily targeted to solve the problem that we have, but it's an interesting idea. The other one where a service can host other subdomains in the DNS entry, somewhat analogous to what external names does, is more geared to just solving the DNS problem. So that's my instinctive feel for this. So
do you think? So sorry. There's the one option, which is to have a default name, a default IP for the namespace name, which the main reason I like it is because it maps to DNS, the way DNS works, pretty straightforwardly. And you don't have to add another level to the DNS names. But it is sort of a more potentially impactful change. The other answer is just to have effectively a wildcard. And it is also pretty straightforward to implement, and it's less impactful. One of the main differences between the two is in the default for the namespace model, you have to create a specific external name record for every bucket you want to serve. And in the wildcard case, you don't. Does that matter?
If the external name itself can have a wildcard, so if you're defining an external name, you can give wildcard.service name, that, and then route that to the stateful set as an example in our context. I'm sorry for the background noise. So that might also be a feasible idea per se.
I don't think that holds up as well. I think if we were to do a wildcard, you'd want to put it on the service. So on your main service, which is saying I don't want the normal child behavior. I want this wildcard child behavior.
Yeah.
And so then the good news is you only have one resource, and it has the wildcard flag on it.
Yeah.
I don't know if the number of resources is actually a value or not. Like, is there information that you'd want to attach to each individual external name?
No, the only thing I can think of is that if there are monitoring or management solutions or security solutions that eventually get built for mapping services names without wildcards to metrics or policies, then having the wildcard might be more intrusive because it kind of breaks it. Versus just having explicit records or resources being created, not necessarily new cluster IPs, but at least DNS records being created for every new entry. That's the only thing I can think of. From a pragmatic standpoint, both work fine. I don't have a strong preference one way or the other.
Okay, let me, I'll send one more quick note on this to the mailing list just so that we capture this distinction, which I guess I didn't really think about before. And then we can proceed to either a single cap or a split cap where we make a decision between the two paths. I don't see any other options, and I don't see any reason not to support this.
Okay. Thank you, Tim.
Thanks, guys. Jay, you got a couple minutes to talk about test cleanups?
I can go fast because I know there's another one after me. There's the TCP close weight. That's not super critical, but I was just going to ask what the future of that test was going to be, whether it's going to be improved or not. And then the other one was that I think is a little more important because I always use it for diagnosing things and have for forever, is the intrapod. If we could do like polling, but I looked back at the way the E2E framework is working nowadays, and it looks like it fails automatically. And if we could breadth first poll, then we could, at the end of the intrapod tests, which I think are kind of the number one diagnostic for knowing if networking is totally broken. So if we breadth first poll, then we could very easily know when somebody submits a bug, whether their networking is just totally broken or whether one node or two nodes is down and the rest of their cluster is up, and so on. I know that's terse. I'm trying to talk quickly, but does anybody know what I'm talking about there?
I'm interested, but unfortunately your audio is a little bit stuttery, so I don't think I fully understood what you said.
Okay. You know what? I'll just type it into Zoom and then we can go to the next person because I know there's more questions.
Okay, sounds good. Or we could just follow up on Slack if you want.
Yeah, we could follow on Slack.
Oh, I think it might be your audio. You're the one who's breaking up from my end.
Yeah, for me as well. Cool. So that we'll follow up in Slack. Rob, you're next.
Yeah, this is really quick. There's a link in the agenda to Service API's pre-alpha review. For anyone who likes to review APIs, especially large APIs, we are looking for API reviewers at this point. This is a full Google Doc actually of the API and Go types, along with caveats at the top that this is still in progress, and I've linked what we're currently still working on, but I think it's ready enough for some API review, and I would appreciate, I know there's some people on this call that are excellent at API reviews. We are hoping to get an initial alpha out in August, and as you know, we're in August already, so we'll see where that goes, but we would love any feedback at this point. The reason it's a Google Doc is this is all on GitHub, but really the only way to review there would be the incremental PRs we've been making. This doc allows you to review the entire API as we have it spec'd right now, and I'll be updating as we make changes on GitHub. But that's all. If you're interested, please leave some reviews, or even better, come to our meetings and take part as we're getting close to an alpha release. That's all I have.
Cool. Thanks, Rob. Anybody interested, please check out that link. And that brings us to our final item from Tim about KubeCon North America.
Hey all. So we haven't even crossed the bridge for KubeCon Virtual EU, but I got an email from Nancy at CNCF asking if we want to do a maintainers track session for KubeCon NA, which is also virtual. So specifically like a SIG network intro and or deep dive session. Because of all the chaos around Europe and everything else that happened, Bowie and I went ahead and recorded that, but who wants to do the one in North America? Volunteers? We don't have to do one, but I would assume we would want to. So we don't have to answer now, but if you're interested in helping produce the material, I mean, we can always reuse material, but to help present and record the session, drop me a note on Slack or email or Twitter or GitHub or whatever, and tell me that you're interested, and I will be happy to help loop you in.
I want to just add to that if it sounds intimidating, keep in mind, this is not a live delivered thing. Therefore, you could do what we did for the Helm session for EU, which is 2 maintainers, recorded, and then we got other maintainers to watch the video and give us ideas of things we forgot to say, and I added them in as pop-up video. So you can totally do things like that with this sort of format. So if it feels like, oh, maybe I'll say yes, reach out to Tim.
That is a super cool idea.
Bridget, what tool did you use to do that? I feel like it was so hard to record that. I was like, driving nuts.
The recording was, we recorded on Zoom, then I gave it to my spouse, who I cheat because he's an audiovisual professional, and he went into Final Cut and fixed the audio sync issues out of Zoom, and then he went into something else. I think it might have been in Final Cut, but I'm not sure.
The only people that can do that are like AV producer specialists, because my co-presenter, her husband is an AV specialist for Twitter and like writes their video streaming code, and he had to edit ours. And it's like, I wish there was an easy way to do it.
Yeah.
Or you can do it the way Bowie and I did this one, which is we used the CNCF's tool, and you get one shot at recording it. Hope you don't flub. And it was fine, but it's not going to be nearly as creative as what I'm hearing from other people. So anyway, it's really not that daunting. Super friendly audiences. Our SIG, in real life, our SIG updates are always very well attended, and they're a lot of fun. So if you haven't done one before and you feel like you're comfortable with the material and you want to step it up, or you want to force yourself to become more comfortable with the material, let me know. Let us know, and we'll help figure it out. It's nice to get different people on the stage doing this.
Great. Thank you, everybody. That is the end of our agenda with 3 minutes to spare. So thanks, everybody, for coming, and we'll see you all in 2 weeks.
Thanks, everyone.
Thanks. Bye.